All right, welcome back. And here on this video, we'll go over the non-calculator section. Or actually, wait a minute, this is the calculator section. So maybe um, wasn't supposed to be using the calculator for all those sections there, but uh, I have it all completely messed up. So my apologies on the previous videos when I showed you like using the graphing calculators. You couldn't, but in most cases, like you didn't really have to use them. I use them for just good measures to show you what's supposed to be happening. But a lot of those questions they expect you to do without using a calculator. But for these, you definitely need to have your hands on one of these things and just make sure that you understand how to do the integrations and derivatives using that as the previous video showed you. So yeah, let's get right into it here. We start with question 76. Now don't ask me why they started question 76. Technically supposed to, this is question 29, starting from where we left off, but there's a total of 17 questions in here and you'll be given 50 minutes. I think that's what it's set up here. Yeah, 50 minutes. Again, you want to spend good about 3 minutes per question for these. There are less questions, but it's actually a lot more challenging to do. Because you're expected to use calculators, you're expected to get the values and making sure that you have the correct answers. The graph of the functions f is shown in the figure above. For which of the following of x is f prime of x positive and increasing? The very first word, it says the slope is positive, which means you can kind of see for yourself what happens if you draw these little tangent lines at these locations. B actually can't be differentiated, so I'm just going to say B is out of the question. When f prime is positive, it means that it can be differentiated and it needs to be positive slope. The only places in which you can have a positive slope are at those two locations. Actually, wait a minute, that's not a tangent line. It's supposed to be here, right? It's going to look like this. So that means that A and D is also out because you have these negative slopes going down. So A and D is out. So we're really down to between C and E. The second part actually gives it away, it's increasing. So how do we determine whether it's increasing or not? Well, you really have to take a look at the curve of these two things. See, the C is situated in such a way that, you know, how fast is the rising happening here? So what I mean by that is imagine if you're on the roller coaster on this kind of like, you know, on this trail. When you're here compared to here, would you be traveling a lot sort of faster or slower? That's the question. So like this tends to be like a really fast drop, but this one here tends to be like kind of like a very slower drop, right? So your acceleration, in other words, how fast your velocity is changing, actually gets slower. Whereas here, you see how the slope from, you know, going up this way, it actually kind of rises as an exponential graph. So the more that you go up, the higher the acceleration that you will experience. I can show you if, like, from the tangent lines perspective, it's very flat from the beginning, but then it kind of goes up like this. Or maybe I should draw with like a different color. That's your acceleration, acceleration, acceleration. And then this acceleration, it actually like spikes up like that. So your velocity is also changing in a positive direction, which means it's actually also increasing. So therefore, your answer for this one is going to be E. Okay. All right, number 77. Let f be a function that is continuous in the closed interval with f of 2 is 10 and f of 4 is 20. And which of the following is guaranteed by the intermediate value theorem, it says. The intermediate value theorem basically states that any values given the start and the finish. So let me just first draw this out. So that's 2 and that's 4, and let's say that's 10 and that's at 20. So at 2 it's at 10 and 4 is at 20. So there's got to be some sort of a graph, right? So let's say that, you know, you have a graph that looks like that, or I mean, it could be like a linear function. It could be just straight up going like this. It could be a curve, you know, it could be just anything that it needs to be. But what you want to have, like, kind of focus on is because this is a continuous function, there's no disjointed sections whatsoever. In order for you to go from point A to point B, from 10 to 20, you need to hit all of these values, like 11, 12, 13, 14, 15, all the way down, all the way up to 20. So for A, when it says f of x equals 13 has at least one solution in the open interval, this actually is the correct answer because there's got to be somewhere in between 2 and 4 that gives you a positive 13 as one of your solutions. Like it could be here, it could be here. It's got to be somewhere within that open interval. F of 3 is 15. Now, it's F of 2 could be 15. Who cares about what the second value is? It could be possible. We're talking about which of the following is a guarantee, which of the following is a must situation. B is conditional. B is like a could be or not. It doesn't really have to happen. F attains the maximum value in the open interval at 2, 4. So you never know if it's going to have a maximum value. What if you have more higher values beyond 4, 5, 6, 7? Like you have a higher values coming upwards. You never know. So C is still very up in the air. F prime of x equal to 5 has at least one solution in the open interval. Now, a lot of us would say that if you were to take the slope of this 20 minus 10 over 4 minus 2, that actually gives you a 5 for this one. So that's why the derivative has to be 5 has at least one solution. Well, the derivative of 5 could happen for multiple occasions. Like it could happen 5 slope here, and then actually it could be 5 slope everywhere. Who knows what's going to happen? It's not really restricted to just one solution. So D is also out. And F prime is it's going to be positive, means it's going to be increasing throughout the entire question here. But I mean, it's certainly increasing, but it could also be a way such that, you know, it could be increasing and then it could be decreasing like this. Like you just simply never know what's going to happen here. I can just erase this. So at certain location, the graph could be in the negative section. So F prime of x could be negative, you know. It doesn't really have to be positive all the time. So the only answer here is just going to be A. So to do these types of questions, I always recommend to draw yourself a little visual to kind of see for yourself what's happening. 78, the graph of y equals e tangent of x minus 2. Now, this is certainly one of those things that you kind of have to draw for yourself. So now let's use a calculator. And we're going to graph e to the power of tangent of x. And then you do minus 2 at the end. Please make sure you move the cursor over to the right-hand side first, so that minus 2 is on the same line as the e to the power of whatever. And I want to set my window to be the same as before. So if you go to zoom and press 6, zoom standard, it just gives you that. Okay. And I believe I need to be in radians mode just to have a better graph. Yeah, there we go. So that is the graph that we're talking about. Oh, I'm sorry. They actually give you the interval of 0, 1. So what we want to do is we want to make x min to be 0 and x max to be 1 like this in our window setting. And there we go. That's the graph what I'm talking about here. So yeah, you're right. The question says they cross x-axis at one particular point, which we can all see like where it's happening here. What is the slope of the graph at this particular point? So we want to locate where that little x-intercept is. To calculate that, we're using a graphing calculator. If you press second trace, which allows you to calculate all these different cool stuff, one of the things that they can ask you to calculate for, you can ask the calculator to do for you, is calculate it to 0. Click the left boundary of where the 0 is going to be. So the 0 is somewhere over here, right? You move the cursor maybe towards the left-hand side of that, gives you a little bar here, and then you keep on going to the right and probably somewhere here. That's a good amount. And if you don't want to, like, you don't want to guess, you just want to press enter one more time. They give you a 0 at x equals 0.6061119, it says. That is the value. If you zoom closely, you can kind of see that, right? 0.606. All right, so I use the calculator and I have the x value, and what is the slope of the graph at this point? So slope, fancy word that represents slope, is called derivative. So they want you to find the derivative when x is equal to this amount. So again, we're going to use our calculator. Actually, we're going to use the capabilities on this, where actually if you go to math, go to the derivative section, and we're going to derive this function in terms of x. So e to the power of tangent of x, and then you do minus 2, and x is 0.6061119, because that's the x value that we found out. We press enter, and there we go, 2.961. That was easy. This is why you want to be very fluent in using your calculators here. Okay, and I believe the answer for that one was D. Yes, there we go. All right, number 79. A particle moves along the x-axis. The velocity of the particle at t is given by v of t, and acceleration is a of t. Which of the following is the average velocity of the particle? When you guys want to find the average of something, you usually add all the numbers up and divide by how many numbers there are, right? So to find out what the average velocity is, normally what you do is you find out what we call the area under the curve. So the area under the curve of the v of t, all the velocities combined together will give you that. But to find out the average, we want to divide just by how many of those things were. The easiest way to kind of indicate this is the average of velocity, average value of something. They follow the formula of multiplying the integration by what we call 1 over b minus a. Highest value minus the lowest value, and then you do 1 over that, because this will tell you like your change in x, if you will. And this will be total y value sum all put together. Since we're doing from 0 to 8, that makes this fraction to be 1 over 8 here. So any answers that I don't see for that, I'm just going to get rid of it. And the reason why I'm getting rid of a, even though I see 1 over 8 for the denominator, is because I do not subtract acceleration. I am subtracting, or I'm not subtracting anything. You're trying to sum up all the velocities together. This will give you the total sum of all the velocities put together. That's what an integration is all about. So the integration of a to b with the velocity given within the given time from 0 to 8. So simply the answer is just going to be b for this one, and there we go. Now, when I first did this, I picked c because I thought the velocity had to be an absolute value function, but that's only to tell its magnitude. But since we want to find out the average velocity, whether it's going to be negative or positive, because velocity, the signs only tell you the direction. Like if you're traveling like negative 40 miles per hour, it means you're moving like south, you're moving in the opposite direction as if you were going north. But in this particular case, because you want to find out the average along with this direction, you don't have to worry about the signs. So you just have to just do the velocity v of t and just get the answer from there. All right, number 80, the graph of f prime, the derivative of the function is shown above. Which of the following statement must be true? So I have the derivative function, and let's take a look at Roman numeral 1, 2, and 3. F has a relative minimum at x equals -3. At these two spots where f prime is 0, that's either max or min. So you really have to check to see if it's actually going to give you max or min here. This part means that the derivative for these, all of these are going to turn out to be a negative. That means it's decreasing. So if I were to just draw the graph of f, from here to here, this part is represented as graph going like downwards. It's decreasing. Then it hits some max or min, then it starts on the positive end of the spectrum. So it's increasing one more time. So what does that mean? It represents this to be a minimum value, just like it will do at a tip of a parabola. So this Roman numeral 1 absolutely must be true. Eliminates a lot of choices for me. The graph of f has a point of inflection at x equals -2. Now, when x equals -2, it means here. The point of inflection is when the derivative graph actually reaches what we call a change in its value. So if the derivative changes from, let's say, being positive, well, actually, wait a minute, no, not derivative. We're talking about the second derivative, because the point of inflection is where the second derivative, the acceleration, turns from negative into a positive or vice versa. So when the second derivative changes its sign, that's where your point of inflection is going to happen. And from the derivative graph, the way that we can find out the second derivative is to try to see what the tangent lines would look like. Now, for tangent lines around here, they will all kind of turn out to be like a positive lines, right? They will all be from moving from left to right. It's sort of like going upward. And then from here, the lines are also still kind of like going up if you try to find out the tangent line. So the derivative of the f of prime, which gives you the second derivative, they're all positive on here, and they're also all positive on there. So at x equals -2, the point of inflection actually doesn't happen there. The point of inflection actually happens here. Because if you take a look at the graph, that's where the graph is kind of increasing, then it's decreasing. Where your first derivative is increasing, then it's decreasing, or decreasing, then increasing, that's when the point of inflection is going to happen. Like, and also if you draw your tangent line, it's a positive slope here, but the tangent line afterwards, this is a negative slope. That's where the point of inflection is. So therefore, Roman numeral 2 is not going to make any sense. So D is actually out of the question. The graph of f is concave down for between 0 to 4. Now remember, for concave down, it means the second derivative has to be negative. But I think it's kind of quite clear between 0 to positive 4. All of your like tangent lines, it just goes downhill. Like it's a negative slope when you draw tangent lines. So yes, it will definitely be concave down. So the answer here is going to be E for this one. Number 81, water is pumped into the tank at a rate of that. So in the beginning, they have an 800 gallons of water where the pump was turned on. How much water to the nearest gallon is the tank after 20 minutes? This is an integration problem. You have a rate. You want to find out how much water is pumped into the tank. From the 0 to 20 minutes, the first 20 minutes as this the water is turned on, that is the rate in which the water is being pumped in. So if I were to integrate a rate, you get the amount. And so this, I'm going to let our trusty calculator to do the work for us. Math, and we go to the integration portion, 0 to 20. Then you do 30 times 1 minus e to the negative 0.16x. Then you do dx, press enter. There we go, we get 420. Now, a lot of us might jump into the conclusion and say, oh, so then our answer is just 420 gallons. But remember, they started off with 800 gallons of water in the first place. So you have to add 800 and get 1,220 gallons for this. That is the final answer for this one. Okay. All right, for 82, we have a derivative function f prime of x is equal to square root of x to the power 4 plus 1 plus x cubed minus 3x, and then has a local maximum at x is equal to. So if they give you this, they're really asking you to solve for where this thing is equal to 0. Remember, whenever you see the word max or min, it means that the derivative is equal to 0, right? Okay, so then all we have to do is just kind of set these two things equal to each other and just solve it. So I think the easiest way to do it is, again, use our calculators here. There's really not much I could do with this other than the fact that I'm just going to use my answer choices to kind of plug it in. If you don't recall how to use this store function that's left of the one, like number one key, I'm going to first try out answer choice A and say negative 2.314. I'm going to store that as x here. So the store button is left key of 1. This is the store button, which is the arrow sign. You see the red highlight. Okay. So then what I'm going to do is I'm going to say square root of x to the power of 4 plus 1, and then I move right 1 and the square root plus x to the power of 3 minus 3 to the 3x. And I get negative 0.0013617189. All right, so that's really close to being like zeros here. So then but it's still quite not 0, right? So let's try like answer choice B, negative 1.332. Store that as x. And then if I just copy and paste the top one, okay, you get 3.69. Now that's certainly, where am I? Oh yeah, this certainly is not going to be a solution no matter what you do. 0.35, I will store that as x. And then if I just plug this into here, you get 3.50, and then you get e to the power of negative 4. That means that you actually have to move increments like 3.5, and you move this left 4 times like this. So it's 0, 0, 0.0. So compared to all the other answers that we had, this one gave you the most zeros so far. So C seems like to be the perfect candidate for this one. I know that this is not exactly 0, but you're looking for the one that gives you the closest to being 0 here. So do I want to plug all the rest of the values in? Yes, absolutely. We just want to verify our answers. So 0.829 for x, copy and paste that. What am I going to get? All right, negative 0.7. That's still certainly not close to being 0 as the first answer, the third answer. And last one, 1.234, plug in as x, and then copy and paste that. All right, so I get 2 zeros, negative 0.00, something for that one, E. But obviously, we want to go for the one that gives me the closest one to being a 0, so that's T. All right, that's now we are down to 83. The graph above gives the velocity v in feet per second, car for t 0 to 8. Of the following, which is the best estimate of the distance traveled by the car? So if they give you the velocity curve and they are asking you to find the distance traveled, if you take the integral, which means the area under the curve, that is pretty much how much the car has traveled within the given time. Like for example, you travel 1 second at about 50, feet per second. So you can just multiply all that and just get the area for this part. And then you get area for this part, and then you can solve it that way. Or another way that there's so many different ways that you can do it, but the way that I did this when I first did this was you kind of look for all the complete squares. And every square is worth about 1 second this way and about 10 feet that way, which means if you multiply them, you get a total distance about 10 feet per square. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 squares, and that's each of them is going to give me 10. I already know that this car has traveled well over 120 feet. Let's eliminate answer choice A and B so for now. So we are really down to these three. Then you kind of want to give an estimate as to how many perfect square shapes that you will get. That's definitely 1, 2, 3. Now you kind of want to estimate this, but combining this one and this one, that will give me 4. And I'm going to combine this one and this one, that will give me 5. That's, I would say, this one and I don't know, this one 6 and 7, like maybe this one 7, and this is 8 completely by itself. And I would say that that's 9. But all you really have to worry about then is just count up the squares. That gives you about 9 squares each, and let's say I add 10, like multiply by 10 to it. Then I get 90 feet for the total area of just this alone. Remember, I'm just estimating it to be whichever the answer is the closest one. So 120 plus 90, that gives me the total distance traveled, which gives me around 210. Like you're counting the as many complete boxes as possible and multiplying by 10. That's all you do. That's all you're doing. All right, 84. For negative 1.5, x is less, x is greater than, and then x is less than 1.5. The first derivative function is given, which of the following are all intervals in which the graph is concave down. Okay, so we want to look for when this function is going to be. The second derivative is going to be negative because that's what a concave down means. I have the derivative function. So what you could do potentially is when you derive this by hand and look for where it's going to turn out to be negative. So the second derivative function of e to the power of x4 minus 2x squared plus 1, you want to take care of the exponent and derive it and multiply in front of e here. So if I derive the exponent, I get 4x cubed minus 4x because that's the derivative of the power here. Then you take that and multiply with e to the power of x to the power of 4 minus 2x squared plus 1. And minus 2, taking the derivative of that is not going to give you anything, right? So this is your second derivative function. And you want to know when this thing is going to turn out to be a negative number. Okay. All right. So here we go. So now what do we do from here? Well, it turns out that if you just compute any number for e to the power of whatever, to e to the power of blob, whether this blob is a negative number, positive number, or whatsoever, you are never going to get e to the power of something to turn out to be a negative. This is not going to happen. This will always turn out to be a positive number. That's just one of those like properties in which you need to know about exponents. Like anything that you raise it to the power by, and you can also see from your exponents that all of your x's will turn out to be positive anyhow. E to the power of that will turn out to be a positive number. That means in order for this overall thing to turn out to be negative, this has to be a negative number in order for this to work out. So 4x to the power 3 minus 4x is less than 0. You're really looking for when that is going to be less than 0. If you factor out the 4x, you get x squared minus 1 as one of the factors in the parentheses. And if you notice, the values in which this will turn out to be a negative here will be something like this. Like I'm completely breaking this down into like 3 sections, and you're trying to look for when.
You get 2 solutions, like x is equal to -1 and x equals to +1 for your values in which this is going to turn out to be negative. Or maybe it's better for me to kind of show you this graphically as to what's going to actually happen. So I'm just going to type this up, 4x to the power 3 minus 4x, and you get, let me zoom standard, and then there you go. You get a little curve like that. But again, they give me a boundary, right? X is between 1.5 and -1.5. So there we go. So we get a really nice curve between -1.5 and +1.5. All you really need to look for is, I don't know if I can screenshot this, but yeah, I don't want to only kind of focus on this one. Where is this negative? That's the question. So this part right here, I can see that's negative on this graph. And this part also is negative on that graph. This here is at -1, and this here is at +1. So what you want to say then is any graph that's -1 or less, and any graph that's between 0 to 1, that's a fair game for me to say that it's going to be a concave down. So the answer for this one will be from -5 to -1 and from 0 to 1. These are not points, guys, by the way. These are like boundaries. This is saying like from -1.5 to -1. That's what it's saying. And this is saying from 0 to 1. That is what those parentheses are indicating. These are not coordinates, by the way. So it's D. Okay. All right. So we have about 7 questions left. So hopefully I'm going to take a little break from the AP Calc, and I'm going to upload a different video to explain from 85 to question number 92. Hope this video helped, and I'll see you in the next video.